So this is about the algorithm. Today I'm going to teach you the basic algorithm for the text classification. A text classifier. So the classifier means a model. A text classifier labels unstructured text into predefined text categories. So the predefined means you already know the label. You already have the label. It learns to classify text based on the previous observation, typically using training data for pre-labeled examples. So you already have the training data and you already have the label. So we call this is the classification. So the algorithm, which is the main of machine learning process, is also known as a classifier. So the model, usually we call it classifier. A classifier is a hypothesis or discrete value function for assigning the categorical class labels to specific data points. So if you have a model, so this model will assign the data point into specific class. So we will assign the class to specific one point or every row. We call it, if we have rows, is one. And for each data point, there will be a new label according to this classifier. So today we are going to learn at least three algorithms. First is the naive bias, NB. So there are two kind of variants of naive bias. We can use multinomial naive bias and we can use the Bernoulli naive bias. And the other algorithm that we will learn is logistic regression. Now let's see an example. We have a corpus. Okay, so we usually say that a collection of text is a corpus. So given 5 sentences in the corpus with corresponding categories. So let's say I have the categories, whether the text or the sentence is in the category of sports or not sports. So you need to use an algorithm to classify whether a new text, which is a very close game, whether it belongs to sports or not sports. So for example, this is the training set. I have 1, 2, 3, 4, 5. So I have 5 sentences. A great game. The election was over. Very clean match. A clean but forgettable game. It was a close election. For every of this data, we have the category. So this text, a great game, the category is sports. The election was over. The category is not sports. Very clean match. So the category sports. A clean but forgettable game. Sports. It was a close election. So this is not sports. Now I have a new text. The text is a very close game. Now, what is the category? So we need to figure out this category by looking at this kind of probability. So what is the probability given that we have the sentence, a very close game, it is belonging to sports? Or the other probability is given that a text, a very close game, what is the probability that it belongs to not spots? So we can make a kind of distribution table. Okay. So we want to extract the feature. So this is the feature extraction. For every of this sentence, we can put the binary. So this is one of the example. You can use binary or you can use the frequency. So let's see this one. So we have one grade is also one, and Kim is also one. Was over. Then the word the is one, the word election is one, the word was is one, and the word over is one. Okay. So we can have this is the feature. So we have the features. Once you have the features, so let's just assume that you want to use these features and you put this into this binary vector representation. Then for the sentence one, the binary vector representation is 1, 1, 1, and the remaining is 0. So we have 1, 1, 1, and then this is 0. Okay. So all of them are 0. Then this is the vector representation for the sentence one. And we know that the category is false. The second sentence, S2, for example, so we can see that these are 0, okay, 0, 0, 0, and then we have 1, 1, 1, 1, and then we have 0, 0, 0, 0, 0, 0, and 0. Then this is 0, this is the feature that we have, and then this is 0. And we can put also the category, which is not spots. So we can also do with the S3, S4, and S5. And we can put the category in the column category. Now, we can also look at the new data. So this is the new data. So the new data or the test data, we also need to create the feature. The feature here is depending on the text that you have. 0, 0, 0, 0, 1. It means here we have a, and then we have very close. Okay, we have close, and we have him. Okay. So after we have this binary vector representation, and we have also the binary vector representation for the new data, now we need to calculate the probability of spots. So what is the probability of spots? Among the 5 data, we have 3 spots. Then we have 1, 2, 3. We have 60% of the data, it belongs to spots. And the probability of not spots is 0. There are 2 of not spots among 5 data. The naive Bayes. The naive Bayes is a probabilistic algorithm based on the Bayes theorem. So the Bayes theorem, we have this probability. The probability of A given B, it is the same with the probability of B given A multiplied by the probability of A divided by the probability of B. So using this formula, we can calculate the naive Bayes result. We call it is naive because it ignores prior distribution of the parameters. So I do not care what is the prior distribution. So for example, I do not know what is the previous probability of A. I do not know what is the previous probability of B, but I just want to know the current probability, and then I can predict this probability. And it is assumed that the features are independent, okay, for all the features and for all the rows. The presence of one feature does not affect the presence of another. So I don't care if there is a word of, and then somehow later there is a word a. Okay, so there is no dependency. So we say that it is independent. So this kind of condition, which may not be true in practice, okay? Because when you write an English letter, when you have is, so is singular, then you may know that if it is a singular, it will be followed by a to represent a singular. So there is a kind of dependency between is and a. So if you use are, so this is plural, many objects. So if you are writing something, let's say there are apples, and it means you need to put s to represent the plurality. Then it means there are some dependency between the R and S, the plurality. But using this naive Bayes, we assume independence, which may not be true in practice. So this is just a simple algorithm. We can look at the algorithm, how we can do the prediction. Using this formula, then we can say that the probability of spots, given that the text is a very close game, then we can convert like this one. The probability of a very close game, given that the category is spots. And then we will multiply with the probability of spots, and we will divide with the probability of the text, which is a very close game. So how can we get those probabilities? So you know that the probability of this spots, this was from the previous one. Spots, it is 0.6. What about the probability of this text? So we learned a lot of prediction from the previous section. So we can use the multiplication. So we can use the multiplication, if you still remember the symbol multiplication. So we can multiply the probability of a. We can multiply the probability of very. We can multiply the probability of close. We can multiply with the probability of game, and then we can get the overall probability. Or if you use bigram, we can use the bigram. Or if you use trigram, we can use the trigram. So how can we calculate this one? So let's see. For the multinomial naive Bayes, we use the frequency. We use frequency means how many times it appears on the feature. So we make the category, which is spots and not spots. If the category is spots, so there are two one rate, there are two the word of came, and so on. So how can we get this one? This is from the feature that we extracted. So we can get this one. The great game is sports. The election was over, so this is not sports. So very clean match. This is sport, this is sports, and this is not sport. If it is sport, sport, and sport, so we just add 1 plus 1. Then there are 2 of the word for the category sport. What about great? So there is 1, 0, 0. Then there is only 1 for the category sport. What about the word game? So we have 1, 0, and 1. Then there are 2 of the word game for the category sports. Then you can do the summation or grouping based on the sports, and we can get this feature for the sports. What about the not sports? Yeah, we also grouping based on the not sports. So after we group based on the sports and not sports, we can use the probability that we already learned before. So let's say we are using the Laplace. So remember the previous algorithm for doing the representation. Okay, so for the text representation, we can have the smoothing. There are 3 smoothing. You still remember? We have add 1 for Laplace smoothing, and then we have add k. So k is a number in between 1 until 0 until 1. Okay, so you can have 0.5 or 0.3, 0.7 something, or yeah, you can have the interpolation. In other case, you can use the back-off strategy if there are 0 for the the representation. For example, if the trigram does not exist, then you check the bigram. If bigram does not exist, then you check the unigram. So that's also the strategy to get the probability. So now let's just use this Laplace at one smoothing to avoid 0. Okay. So we have the probability. So we want to know what is the probability of that word given that the category is sport. So I know that the category is sport. Now I want to know the word a very close game. Okay. The word a very close game. So what is the probability? So we already learned if we have this probability of that word given the spot, then it is the word count in spot plus 1. It is to avoid the 0 divided by the total word count in spots plus v. So v is the vocabulary size. So you can also look at the total word count in spots. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 words in spots, and 1, 2, 3, 4, 5, 6, 7. So there are 7 words in not spots. For the vocabulary size, yes, means we have in total. Okay. So in total, we have this total is 14. So we can have the probability. for every word. For the word a, given that it is the category in sports, then the word a in the sports. So there are 2 plus 1. This is to avoid the 0. And divided by 8, the total word count in sports, plus 14. Then we get this value. So this is the probability of the word a in the category sports. And then we can calculate for the other word. Great. We have the word of very great game. Then great, given that it is sports. So great, we have 1. So 1 plus 1 from this one, and 8, because there are 8 total words in sports plus 14. So the probability of great is 0.091. What about the probability of A in the not sports? So the probability of A in not sports. So we have 1 plus 1 because it is the formula from the Laplace, and then divided by 7. 7 is the total word in the not sports. Okay, for not sports we have only 7 plus 14, which is the total vocabulary size. Then we have this value. Okay, based on this, now we can calculate the probability. So this is the probability for every word. This is the probability of a in sports. This is the probability of a in not sports. This is probability of great in sports. This is probability of him in sports. So for this one, yeah, you can try by yourself. Okay. This is actually not 0, but it's very small. Okay, because we have, if the great not sports, it means 0 plus 1 divided by 7 plus 8. So we have 1 divided 15. It's very small. Okay. Then we can look at the posterior probability. So what is the posterior probability? We can check what is the probability of sports given the sentence. So the sentence is a very close game. Okay. So a very close game, it means it is the multiplication. If you look at the formula, when we have the probability of spots given that the sentence, so it is, we can have this kind of prediction that the probability of spots multiplied by the probability of a given that it is in the spots, multiplied by the probability of the word very given in the spots, and probability of close given that it is in the spots, and probability of the word game given that it is in the spots. Then yeah, we have this probability 0.6. It means this is the probability in the spots. Then you can also look at the probability of a given it is in the spot. The probability of the word very given that it is in the category of the spots. The probability of the word close given that it is in the category of sports. Here. And then the probability of the word game given that it is in the spots. Game, this one, game. Okay. So you can just do the multiplication. And after that, you will get a value. This is the probability if we want to see the word a very close game, and if it is belonging, the probability is this one. Now let's check. What about if the sentence belong to not sports? You can also check the same way. So we can do with the multiplication. The probability of not spot, it is 0.4. And then we want to know the probability of a in the category not sports. The probability of very in the category of not sports. Okay, so as I mentioned to you, I didn't write this one. It means that it is not 0, but you need to calculate because there is no vary in the not spot, so it is 0 plus 1 divided by the number of words in not spot is 7 plus 14, the total vocabulary. Okay. So it means 1 divided by 21. Okay. So 1 divided by 21, it is about maybe this one, 0.048. So the probability of vary on not spots, this one. The probability of close on the category not spot is this one. And the probability of game in the category of not spots is very small. So if you look at this one, by intuition means the word vary and the word game, okay, the word game and the word vary does not exist in the not spots. If it does not exist, it means the probability will be very, very low. Because the probability will be very low, the result also will be very low. And based on this posterior probability, we select the highest one. What is the highest one? 0.00000384 compared to 0.00000083. Then this is the highest. In this case, then we will choose the probability of spots. Then the sentence will be classified as spots. Okay. So there is also another variant for the naive bias. For the naive bias, we have the Bernoulli naive bias. Use the binary features. Binary means the word exists or not. We don't care how many times in the sentence or in the category. So in this case, if we are using the category spots, regardless the frequency, we just want to know whether this word appears or not. This word appears or not. This word appears or not. So exists or not. So then this one can be like true, false. 1 is true, 0 is false. Then we can do again with the probability, like what we already did in the text representation. So now let's just use the 1 divide the 0, and then we put 2 for the denominator, the very small value. So usually we put this one, okay. This one, you can use the total of the words. Okay. So if we use the V, it is the total vocabulary. But if you use the total vocabulary for this one, it means you will have a lot of value and the value will be very, very small. This is only about the axis or not axis, or we have 1 or 0. So that's why we better to avoid the very high number of words, and usually we just put 1 or 2 because the option here is only 0 or 1. Okay. The belongs to the category sport. So we have okay, 1 plus avoid the 0 divided by the total sports document. So we know that there are 3 kind of sports. There are 3 documents of sports, and then we just put a value 2 to represent there are 2 options of the value, 0 or 1. For sometimes, this one you can set up with any value to avoid 0 as long as it is higher than 0. So we have the 2 divided by 5, then it is 0.4 for the word in the category sports. What about the category sports and the word is game? So this is also we have 1, and then among 3 documents in the sports, we have this probability. And what about the probability of in the not sports? Then we have 1 divided plus 1, and for not sports we have 2 documents. Okay, for 2 documents plus 2, then we have the higher probability, which is 0.5. With the same kind of probability, okay, so we have the sports, and then we have the probability of in the category sports. We have the probability of the word great in the category sports, and so on. Now we can check the posterior probability. Again, we calculate by the multiplication. We look at the probability of sports given that the word are in the category of sports, the word very in the category of sports, the word close in the category of sports, and the word game in the category of sports. So we just use these numbers. Is 0.4, very 0.4, close, okay, because close is 0. It doesn't mean 0 in this case, but you need to calculate 0 plus 1 divided by the total number of document in spot, which is 3, plus the index to avoid 0. So it is 1/5. So the probability is 0.2. And then we calculate the probability of Kim in the category of sports. Then we can get this probability. Now you need to check also the probability when it is in the category of not sports. So you can do again the calculation like this one. Okay, this is the probability. Based on this result, what is the highest probability? So we can see this is the highest probability. In this case, okay, this using the Bernoulli naive bias, there is a high chance for the text it belongs to the sports. Okay. For the logistic regression, okay, let's have a break. Okay, I will continue with the review.